Hey, my chemistry minions, video number 6. Today we learn about isotopes and average atomic mass and how to calculate them. So that's what your learning target is for today. This one's going to have some math to it, but it's not the most complicated math. This picture shows perfectly what an isotope is. Hydrogen. Every hydrogen has one proton because protons are king. One electron cancels it out to make it an atom. What's different is I add neutrons, which changes its top number, its mass number. So there's hydrogen 1, which is normal, hydrogen 2, which they call deuterium, and hydrogen 3, which they call tritium. And you'll never get tested on deuterium or tritium. What you need to know is that same element, different mass. Different mass, that is what we call is an isotope. So an isotope is an atom, same number of protons, but a different number of neutrons, giving it a different mass. Notice the mass in this example is all different. Okay, 1, 2, and 3. The symbol and the atomic number remain the same, but the mass number will change. So this is where, when you're doing the practice from 2 videos ago and last video, things can get a little bit confusing because we hadn't formally done this. Okay, so if I give you the number of neutrons that's different than normal, you have to use that in calculating the new mass. Now, the average atomic mass is this decimal. So what happens is I take the atomic mass of each of each element, its isotope, and I average it based on its naturally occurring isotopes. Now, I have to give you what those percentages are. You wouldn't know them. So then what I need to do to calculate this number now is 2 things. I need to know the mass of each of the isotopes, which might not exactly be 12. In carbon, there's 12 and there's 14, and there's actually 13 too. And then the relative natural abundance of each, how much of each isotope there is. And then I'm just going to change that I'm going to change that decimal into, I'm sorry, I misspoke, getting ahead of myself. I'm going to change the percentage back into a decimal. So here's the actual way to do this. I'm going to take the percent abundance of an isotope in decimal form and multiply it by the mass. And that's of 1, and then again of 2, and again of 3. Percent abundance in decimal form. Add up all my answers, I have the average atomic mass of that particular element. We do a few of these, this will make sense. Now this one's going to be animated. There's different formats. I do not want you to get hung up. It's the same thing in each format. So I need to multiply the mass, okay, times the relative abundance. So the first example, the mass is 12, that's that top number. And then I'm going to multiply it by the percent abundance in decimal form. So I'm going to bring it right over. If I divide anything by 100, I'm just going to move the decimal place to the left 2 times. Wait, this for you, right, on the camera? So I'm going to take that and I'm going to turn that into 0.9889. What did I do? I divided that percentage by 100. Remember, it's always part over whole times 100. I have to divide it out by 100 if I'm actually going to use it in any kind of mathematics. So there you go. I just did 12 times 0.09889 and I got a number. Okay, good. Now I need to do it again for the next isotope. So the mass of this one is 13. 1% of it is 13. Again, in decimal form, and I get an answer. Then, next step, add them all up. Add up the products of all the calculated isotopes, and I get a number. Boom, and that's exactly what the number is for carbon on the periodic table. Okay? Good? Okay, deep breath. All right, now this one, I don't have it animated, so I'm going to have to use a handy-dandy calculator. I'll pull that up on my phone, and I'll step to the board and do the same thing. So again, the mass of hydrogen is, of protium, the first hydrogen is 1, so I'm going to bring that over. That's going to be 1 times 99% in decimal form is 0.99. 1 times 0.99 is 0.99. Okay? Then I have a mass of 2. Wait, let me change colors. A mass of 2, that's going to come on over. 2 times 0.06. When I move this over twice, that's going to be 0.06. Right? 0.006. Okay, and I multiply that by 2, that is going to be 0.012. Okay, and then tritium is 3, so I'll bring my 3 right over. And I'm going to move this over 2 times, so that's 0.004, which is 0.012. Sorry, getting a little sloppy. Then what do I do to all those numbers? I add them up. So I'm going to say 0.99 plus 0.012 plus 0.012 equals 1.014. Gives me my answer. Add them all up. And I get 1.014. And let me look up at hydrogen, see if that's right. And I get, 0.0794. But that's all right. That's what this is in this particular example. Let me check my math. I did that in my head. 0.006 times 2. I got that one right. And 0.004 times 3. Got that one right. All right, so that's the answer for this particular problem for hydrogen. Okay? Explain how you found the average atomic mass. Well, I'm going to multiply the mass of the isotope by its percent abundance in decimal form. And then I'm going to add up my answers. There you go. We just learned how to do it. Now we just need to do some practice and we're going to be all set. You ready? Done.